Come here. Shh, closer. You have no idea how long I've been thinking about this moment.
Okay, let's talk about that voice you just heard. It sounds pretty human, right? Almost a little too human. But here's the crazy part. The person speaking, they don't exist.
Yep, it wasn't human at all. What you just heard was the voice of an artificial intelligence. And this isn't some supercomputer in a secret lab. No, this is an AI you can run right on your own computer, for free.
So today, we're diving deep into a really powerful new tool that's, well, kind of shaking things up in the world of AI voices. It's called Chatterbox Turbo, and because it's open source, it's basically throwing down the gauntlet to all those big, expensive services out there.
All right, so what exactly is Chatterbox Turbo? Well, at its core, it's a text-to-speech model. You give it text, it gives you audio. Simple enough. But its secret sauce, the thing that makes it so special, is its focus on real-time performance. The whole idea is to get a voice that sounds genuinely human, but without that annoying lag or the need to pay for some massive cloud server.
And what it promises to do is, honestly, pretty incredible. We're talking high-quality speech that actually has some emotion to it, Not that flat, robotic voice we're all tired of hearing. It's also super compact and efficient. But the two biggest features, these are the real game changers. First, it can clone a voice from just a 5-second sample. And second, it does all of this locally, right on your own machine.
So the big question is, how did they do it, right? How did they manage to cram so much power into such a tiny, efficient package? Well, the secret is all down to some seriously clever engineering.
Okay, to really get this, we need to talk about one specific part of the tech, something called the MEL decoder. Now don't worry, it sounds complicated, but just think of it like the engine of the whole system. It's the part that takes the text and turns it into the actual frequencies that make up a voice. And in the past, this step was a huge, complex bottleneck.
And this is where the breakthrough happened. They used a technique called decoder distillation. What that means is they basically took a clunky, super inefficient 10-step process, and they distilled it. They boiled it down to just one single elegant step. And the result? It uses way, way less computing power, but you still get that same high-quality voice.
And what does all that amazing efficiency get you? Well, it gets you this number, 4.5 gigabytes. That's the VRAM it needs. Now, to put that in perspective, that is incredibly low. You absolutely do not need some monster gaming rig to run this thing. In fact, it's designed to be accessible for just about anyone.
Okay, so the tech is clearly impressive, that's for sure. But that's only half the story, isn't it? The real question, the one we all care about, is how does it actually sound? Let's listen in and put it to the test. First up, let's imagine a customer service scenario. Now, listen to the tone here. It's trying to convey empathy, right? A little bit of surprise even. The pacing feels pretty natural, way more conversational than your standard "your call is very important to us" robot. You can immediately see how this could be used for, interactive AI agents. All right, now let's try something with a bit more energy, like a podcast intro. You can hear that excitement, right? It's pretty solid. Now, the original analysis did flag a few little glitches, some unnatural pauses and things like that. So the emotion isn't perfect, but you can tell it's really trying to get there. The overall delivery is surprisingly natural.
But okay, of all the cool things this can do, there is one feature that just blows the others out of the water. And that's its ability to clone a voice. Just think about this. It listens to someone talk for just a few seconds, and from that, it can learn to replicate their voice and make it say, well, anything you can type. So, the million-dollar question is, how accurate is it really? Let's do a head-to-head comparison. First, listen to this. This is the original human voice sample that the AI learned from. And now, listen to the AI using that cloned voice to say something completely different. I mean, wow, right? The similarity is just uncanny. It captures the tone, the pitch, the rhythm. It's not a 100% perfect copy, of course, but for something generated from such a tiny sample, that is just astonishingly close. And this quote from the source material really just nails it. The verdict is that the voice cloning is really, really good. That's the star of the show here. Sure, the emotional range could use some work, but the core tech, the ability to replicate a voice this well, that's a massive achievement. So, let's zoom out for a second. What's the big picture? Why does a free tool that runs on your own computer matter so much? It matters because it's a direct challenge to the status quo, to the way things have always been done. See, for the longest time, the best AI voices were locked away behind expensive cloud-based subscriptions.
You had to pay to play. Chatterbox Turbo just flips the whole script. It's free. It runs on your hardware, which means you own your data, and you can even use it offline. And because it doesn't need a supercomputer, it's opening the door for a whole new wave of creators and developers.
So, let's just boil this down. Why does this really, truly matter? Well, first, it's about democratization. It puts professional-level tools in the hands of indie creators, people who could only dream of affording them before. Second, and this is a big one, privacy. Your voice samples, your data, it all stays on your machine. End of story. And finally, it's about innovation. This is just more proof that the open-source community is a powerful force, pushing the boundaries of what AI can do for everyone.
And all of this really leaves us with one final big question. We've seen how powerful and accessible this tech is becoming, so it's not a matter of if we can create these voices anymore. The real question is, what are we going to do with them? When anyone, anywhere, can create a realistic AI voice on their own computer, what new stories are going to get told? It's a pretty exciting, and maybe a little wild, future to think about.